Hello and a warm welcome to the series of an overview on precast construction technology, Lego construction. So in the first video we have already seen about the hollow core slab, that is a dry product. So now we will move on to the RC products, that is known as the wet product. So let's move on to the further slides. So this will be our flow of the content. So first we will see about the precast construction technology. Then we will move on to the manufacturing process, where we will see how the molds are made, how the elements are casted, and then we will move on to the design and connection part of the elements. And then we will see the tolerance that are permitted by the Indian standard code as well as the foreign codes. And then lastly we will see the logistics and erection of the elements. So let us first understand the difference between the traditional construction and precast construction. So if we talk about the traditional construction, so traditional construction is a step-by-step construction in which each and every activity are performed on the site, where there is a requirement of the shutters, and it is also a time consuming as compared to the precast construction. There is a chance in lack of curing and quality, where the huge supervision is required, and there is a chance of getting the extension in the project timeline, which is ultimately a huge loss. So whereas if we talk about the precast construction, so this kind of construction is like it is a pre-planned kind of construction in which each and every elements are pre-planned, and that is executed uh, on timely basis, and then the erection will be done. After that the elements will be transported and erected in the position with the high accuracy of supervision and precision in controlled environment. So here on the bottom left hand side picture you can see that this is the precast column and this is precast beam, and from the top another precast column is erected. That is, you can see the finishing and site condition that is far better than the cast in situ part. So here there are some of the advantages of using precast construction technology. So the first, we can say that this is the design optimization. Secondly, it is safe and sustainable site. Then third, it comes like optimization in the resource management, and we have energy efficiency solution as well as improvement in the environmental quality. So these are not the limits, there are other benefits also. So yeah, so these are the major advantages that plays important role in the contribution towards the environment and safety. So if we talk about the process in the precast construction technology, so in precast it starts from the concept and planning. That is the first phase where the concept and planning will be a huge and a very crucial role in planning the elements. Then the second step that comes is like design, where each and every elements will be designed and it will be splitted in number of elements depending upon the element type and site conditions, where we have to use the crane for the erection as well as the transportation, which plays an important role to decide the element sizes. After the design, the production will be proceed, where where the elements will be casted in the factory as per the planning and as per the requirement. And then after the production, the element will be stored on the factory stockyard, where it will be treated fruitfully with the curing and finishing and everything. And then the element will be transported in the special logistics, and that will be properly look for the to avoid any damages, so that element will be placed in a special transporting equipments, and then the loaded material will be transported to the site where the material will be offloaded by the special crane requirement, and then the erection of the element will be done directly from the uh, trailer. And then lastly, after the erection, the elements will be the elements will be completely finished, and that will be hand over to the client. So this is the full process starting from the concept to the handover to the client. So there are various precast elements such as hollow core slab. That this For the hollow core slab we have already seen in our first video how the hollow core slab are made, and how what is the concept of hollow core slab, how it works. So if you haven't watched this video on the hollow core slab, so you can see my first video on this series, you will get the hollow core slab. Then moving on to the another elements, we have precast beam and columns, and then we have precast landing as well as precast staircase, and then we have special kind of elements also. These are not the limit in the elements. There are many elements that can be casted. So yeah, that is the benefit of using the precast technology, that the concrete can be molded in any of the shape that is required. So if we talk about the special elements, we have dome type of structure, uh, we have chimney structures, then any kind of special elements can be produced by this technology. So the main uh, agenda of this video will be the precast wall panels. So in this video we will talk about the wall panels. The wall panels, which means it includes the retaining wall, it includes the load bearing walls, it includes non-load bearing walls, it also includes the shear wall, or we can say load bearing walls, as well as the insulated panels. So generally wall panels are vertical elements, so that can be used as load bearing as well as non-load bearing, or we can say a partition wall. So in this picture you can see this is a two-story retaining wall which is erected on the side. So here you can see it, there is a nib, or we can say there is a recess in the panel which reduces the thickness of the panel, and this total height is around 10 meters, and the width of the panel is around 3 meter. So you can see this is the precast element that is erected using special lifting equipment. So let us see how and what are the stages in the reinforced concrete elements. So the first stage is that the preparation of the mold, in which as per the drawing, the mold will be prepared in the factory, and the reinforcement cage will be prepared side by side. And on the second stage, after the preparation of the mold and the reinforcement cage, the reinforcement cage will be loaded into the mold, or we can say the reinforcement cage will be lifted and placed into the mold, where the requirement accessories will be tied up, and then the concreting will be done. And in the last stage, the element will be lifted after achieving the required strength, and then it will be transported or delivered to the site and erected, uh, and it will be erected on the site. So if we talk about the its production, so there are steel tables. So here in this figure you can see this is the steel table, which are known as a tilting table also, because it gets tilt up to 90 degree when for lifting of the panel from the table. So these are the steel tables which generally comes in a size of it has a width, or we can say height, of 4 meter, by this length is up to 12 meter. So this kind of table are operated by hydraulic system. So it has a hydraulic jack below, which lifts the table from the bottom. So let's say this panel has to be casted. So this kind of panel will be cast on this table. It has the side it has the side shutters, or we can say sides of the sides as per the drawing it is made. And then the window, you can see there are two windows. Similarly, there will be a shutter for the window, which will be made on this table, and then reinforcement will be loaded, and after achieving the strength, it will be lifted with lifting this table up to required degree, and then it will be just simply uh, removed from this table using crane. So you can so here we have IS 15916, that is 2010, which says about the building design and erection using prefabricated construction. So in that it has given all the process how this precast elements are designed, and its erection is discussed. And we have also another code, that is IS 11447 1985, which says about the code of practice for construction with large panel and fabrications. And here on the right hand bottom side, you can see this is the panel, and as this is the small panel, so we do not require to tilt the table, that is directly lifted by the hook. So here you can see there are two lifting hooks, and that hook is locked with this chain sling, and then it is just lifted using the crane. In case of heavy panels, we have to tilt the table. So there is a requirement of tilting the table, because to avoid the damage, and to smoothly lift the panel without any damage. So here you can see how the table has been tilted, and how this panel is easily removed from the table without any of the damage to the product. And here you can see this is the casting stage, where this is the side shutter that is placed. 1, 2, 3 and 4 side shutter is placed, and then the reinforcement cage is placed inside. And then here you can see there is a lifting horizontal lifting hooks are provided. So here the four lifting hooks are there, and here you can see this is the nib on which this hollow core slab will be resting. So we have in our hollow core slab video, we have already discussed that what is nib and why it is required, and the purpose of the nib, which is very important requirement to rest the hollow core slab. So here in the panel you can see this is the nib portion, this is the height of the nib, or we can say the projection of the nib is 150 mm, in which the hollow core slab will be rest. So here in this chart you can see this is the chart for the loading capacity for the lifting hoop. So here you can see this is the lifting details that is provided. Generally for lifting of this panel or precast elements, generally strand wires are used, or our HYSD steel are used, in which the steel pipe is also used at the radius to protect the reinforcement bar or the strand wire. So that will distribute all the forces throughout the area. So this is very important while making the lifting. It is necessary to place the steel pipe, hollow pipe, into the strand wire at the radius part, to avoid any damages and ease in the lifting of the element. So here we have seen this is the solid panel this is 150 mm thick solid panel, and now we will discuss about the insulated panels. So what is the difference between solid panel and insulated panel? So if we check the solid panel, in solid panel there will be fully, it will be covered with the concrete, so there will be no insulation in this particular panels. So if we talk about the insulated panel, so in insulated panel there is a insulation material in the center. This kind of panel is also known as the sandwiched wall panel, in which the bottom layer will be concrete, and in between it will be having insulation material, and at the top again it will be a concrete. So the use of this kind of panels are to reduce the temperature of the inside the room. So these are very useful panels for where we can control the heat coming inside the room. So here in this figure you can see this is the total thickness of the element, that is 250 mm thick panel, in which the first layer, that is the external part, the external layer of the panel is 70 mm, and we have 70 mm insulation material, and this 110 is the outer layer where the hollow core slab will be rest. So this part, this 1110 is very important. That is also known as the minimum bearing requirement. So as per the standard, the minimum bearing requirement will be length of the panel divided by 25. That is the standard requirement. So let us say the length of the panel is or we can say height of the panel is 3 meters, so 3 meter divided by 25, so whatsoever the value comes, that should be the minimum bearing required for the insulated panel. So if we talk about the insulation material, that is, here you can see the different thickness of the insulation material. It comes into 20 mm, 25 mm thick, then we have 50 mm thick, 70 mm thick, depending upon the requirement. So that is expanded polystyrene insulation, here you can see in the picture. And in the second, or we can say on the center figure, you can see there is a top reinforcement, there is a bottom reinforcement, and in between there is insulation material that is used. And also here you can see the red dotted line, that is the steel reinforcement that is used to connect this insulation material with the reinforcement. And yeah, in this, here you can see this is a TI is the thickness of the internal wall. In our case the internal side is 110. Tn is the thickness of insulation. This is the insulation thickness, that is 70 mm, and we have To, that is thickness of the external panel, that is in our case that is 70 mm. So while the selection of the insulation material, it is very important to understand the U value. So what is U value? So U value is the capacity of it is generally a capacity of reducing the heat, or it will avoid the transfer of the heat from the external side to the inside the room. So here you can see this is the panel, and here we have the hollow core slab, and sometimes we have the sometimes we also have the nib over here, in which the hollow core slab will be rest on the top like this. So here we have seen we have the nib over here. Yeah, so this is the nib part. Okay, so this is generally insulated panels, which are most probably used as an external wall panel to reduce the heat that will be that is penetrated from the wall, and it will make the room cooler as compared to outer environment. So here it is the best example you can understand by this concept. Let us say we have the external part, and this is my external part, or we can say the external layer of the concrete. In between we have the insulation material, that is This is my insulation material, and this is my internal, or we can say the bearing part or internal side of the wall panel. So here the hollow core slab will be rested. So if we compare the loss of heat using this insulation material, that will reduce the heat by 50 to 55 percentage, as and it reduces the temperature by 50%. That will that will reduce, ultimately reduces the requirement of air conditioning as compared to the solid wall panels. So this is how, this is the effect of using the precast insulated panels, or it can also be identified as sandwich wall panel. So if we talk about the connection, vertical connection of the panels, we have dowel tubes. So here you can see this is the dowel tube that is used, that is also known as corrugated dowel tubes, that are placed in position. So this here you can see these are placed in position with before concreting. So first the mold will be prepared. Here you can see this is the side shutter, both sides side shutter are there, and this is the bottom shutter. Then we have placed the reinforcement cage, and we have added this pipe in between to the reinforcement, top reinforcement and bottom reinforcement of the cage. And this pipe will be tied up with the this bar using this wires. So this here you can see this is the double tube that is shown in the figure. Yeah, so this kind of double tube will be used inside the element to connect the panel with the bottom element. So let us say this is my receiving element, which is already a precast element, and in which we will give one of the bar that is known as dowel bar. Here you can see this is the dowel bar that is coming out from the bottom of the panel, and we have this other panel which has a dowel tube inside it. So it will be connected with the dowel bar, that will be a receiver bar from the element below. So this is how it will be connected using double tube. So there is a thumb rule of the requirement of minimum diameter of the sleeve. If the receiving bar from the below is 16 mm, then we should the diameter of the double tube should be 40 mm. Similarly, if the receiving bar is of 20 mm, then the sleeve dia should be 40 mm. And if it is 25 mm rebar, then it should be a 50 mm dowel tube. And if it is a 32 mm dowel that is coming from the below element, then the above element should have a 65 mm of a dowel tube to receive and connect the panel. And lastly, we have 40 mm diameter, in which we have to use 80 mm dowel tube. And after the dowel tubes will be grouted with this special cementitious grout that we will see in our further slides. Yeah, so the best view of, or we can say the best assumption that you can see over here. So this, let us say this is the RC footing. So here you can see this is the RC footing, in which the dowel bar is projected out from the footing to connect the wall panel. So here you can see this is one of the precast wall panel. Yeah, here you can see this is the precast wall panel, and here you can see there is a hole, that hole is of the dowel tube that we have placed inside. So here you can see this is the dowel tube that we have placed in position, and this hole you can see this is the hole which you can see this part of the hole. So now what happens, the panel will be the dowel tube will be passed through this reinforcement, and then this reinforcement will be grouted, or we can say this hole will be grouted with this special grouting cementitious grout, which is high strength grout. Now we have already seen the vertical connection of the element. Now let us see how this uh, panel to panel connection is done. Let us say this there is a joint between this two panel. So this two panel has to be connected with some of the material like this. We have already connected this panel with the ground, but we have to connect the panels in between. So for in between we have two types of connections. So first we have is known as the wire loop connection. So here you can see this is the box that is known as the loop box, or we can say wire loop, that is used to connect the panel between. So here you can see this is the two wire loop box that are placed. So let us say this is the panel 1 and panel this is panel 2. These are the two individual panels we have casted as a precast element. So while casting there will be a shutter in this part. So while making the shutter we will make this kind of groove which is known as the C groove, and in this C groove we will tie up this kind of loop box that is available in the market, and then this using this loop box the two panels will be connected and it will be interlocked using a locker bar. That here you can see this is the locker bar. From here you can see this is one of the wire that is coming out from the loop box from panel 1, and here we can see there is a wire coming out from the loop box from the panel number 2. So from both of the wire will be locked with using this locker bar by placing it between this wire. So here you can see this is the panel to panel connection. Here you can see this is the L type of connection, and you can see this is a 3 junction connection. So in this case we can use the wire loop box, which is very famous kind of connection in case of panel to panel connection. So if we talk about the code, we have IS 15916 2010, and we have EAD 2020, which talks about the wire loop system for connecting the precast and cast in situ elements, or we can say precast to precast elements also. We use the same concept. So here you will get the clear picture. So let us assume this is my panel 1 and this is my panel 2, and we have already prefixed this kind of loop box inside my panel, and then after the at the time of erection this wire will be there. So both side there will be a wire like this, like this. Similarly, from each of the loop box there will be a wire, and then a locker bar will be inserted throughout this wire. So these are now connected, and then this gap will be filled by this gap will be filled using a special high strength grout, cementitious grout will be used. So here you can see how the forces are transferred in between. So this is very common, and it is very useful connection for the connection between the panel to panel. And here on the top figure you can see this is the one of the sample for making the groove on the panel. So here you can see this is the C groove that is created. So that is created by using this kind of profile that will be cut and bent in the factory, and then it will be welded with this side shutter. Here will be a side shutter, and then this segment will be welded with this side shutter to create this kind of shape. Now let us discuss the type 2, where this kind of connection, type 2 type of connection, are very used in case of retaining wall where we need a watertight structure. So this kind of type is also known as infilled concrete joint, in which, let us say this is my panel 1 and this is my panel 2. So we will project a U bar coming from the panel like this, which will be having of coming out from both of the elements. So we will have like this kind of U bar that will be coming out, and there will be a locker bar again that will be connected throughout, and then this part will be shuttered. Here the shuttering will be done, and then the concrete will be poured inside. So you can see this is the joint, concrete joint, that is in between two of the elements. So the major difference is in this kind of connection, which is infield connection, you will see the joint, but this kind of joints are useful in case of retaining wall structures where we required water tightening and a perfect connection between the two elements, where this kind of connections can be used in above ground level, where we need to connect two panels easily without any additional formwork or for a good aesthetic views. Yeah, so this is the infill type of concrete joint that we have seen. So it can be either panel to panel, that is this case. It can be either in L-shaped connection, or it can be either three panels that can be connected at a single junction, or it can be a four sides connection junction as well. So here you can see this is the panel with the beam. So we have this load bearing panel, this we have load bearing panel, we have the corbel over here. So this corbel will be used to support the precast beam. So precast beam will be connected like this, and here we will have another corbel with this dowel like this. So this is how this corbel will be used full. And here we have one of the beam that is projected outside, and also we have another corbel here. So these all corbels will be used to connect the precast beam. Here also you can see this is the corbel projecting out from the panel, and here you can see the pre-finished surface of the precast element, with which also has the door opening inside it. So this is the door opening we have, and you can just feel the quality of the precast element. So here we have seen this is the corbel that will be used for the connection of the beam, and this is the bar, projecting bar. So this bar will be help to connect the panel that will come above. So these all are the dowel bars that we have already seen. So let us see that dowel bar. So here you can see in case of this footing, these are our dowel bar, but in case of wall panel there will be, so in case of wall panel we will have this as a dowel bar. Now let us say how the panels are installed at the site. Before it, I will let me explain this kind of grooves that are made in the panels. So here you can see there are many grooves that are given in the panel. So these grooves are used for the plumbing facilities, where the plumbing pipe will be placed inside, and then this grooves will be covered using special materials. So this is the flexibility where each and every tiny things are looked into, and it is pre-planned, and it increases the speed of the construction as well. So if we talk about the erection of the element, here you can see this is one of the element, this is panel 1. So it is having a dowel bar here and dowel tube connection from the bottom. It has a wire loop connection in between the panels, as we have discussed the joint types. Now after erection, it is very important to prop this panel. So to prop this panel, we will fix one end of the prop here and another end of the prop at the bottom. So here you can see step number 1, where this panel is erected on position, where wall lowered to ground using nailed bar. So we have, in this case they have said as a nailed bar, but in our case we can also say as a dowel tube, or dowel bar. Now after the erecting this panel, the alignment will be done using this prop. So the prop system will be, one of the end of the prop will be fixed on the wall panel and another will be fixed on the ground, and then it will be aligned. So here you can see the this panel is fixed and aligned properly, and then the grouting will be done. So by use from this hole, the special grout, cementitious grout, will be filled inside so that this wall panel will be connected properly. Now after the grouting, the joints between the panel will be filled using the sealant. So this is the panel 1 and this is the panel 2. So this is the joint between the two panels that is shown over here. So it is important to fill this joint with the sealant material to avoid the penetration of the water. So here you can see first the becker rod is placed inside the or we can say the becker rod is fixed between two panels, and then this is the sealant that is used for as a waterproofing material that is filled between two panels. Here you can see how this is applied. So after that it will dry and it will create a rubber type of layer which will avoid the penetration of the water. So here you can see this is the precast panel with the chhajja. So it also has a chhajja which is already casted with the panel, as well as it has a window over here. So you can see the beauty of the precast, in which the panel is already prefabricated or precast with the chhajja as well as the openings that are required. Now here you can see this is the this is infilled type of joint between the panels, because this is the retaining wall and this is the total height of the panel, that is 2-story height, roughly 9 meter to 10 meter of the height. And then here you can see this is the nib which I was talking about. So here you can see all the nibs are provided where the hollow core slab will be rested like this, and here also we will have the hollow core slab that will be rested on this nib. So the nibs are very useful to rest this slab. And here you can see there are the joints. These are the infill joints that are concreted between two panels. So if we talk about the curing of the panel, the curing can be done manually, as well as steam curing can also be done. So in this case, here you can see this is the gunny bag that is used to cover the precast element, and here this is the nib portion that we have already discussed. Here also we have the nib, and this is the U-bar that are placed in position to connect with the other precast wall panel. And maybe here in the below you can see these are the dowel tubes that are placed in position to receive the dowel bar from the below panel. So yeah, so this kind of gunny bags are used for curing of the precast element. Then let us see the tolerance that is allowed as per manual 135, which says about tolerance manual for precast and pre-stressed concrete construction. So this is the similar kind of panel that we have already discussed. We have the panel, we have the nib, we have window openings, we have the thickness of the panel. So the overall height of the precast element, if the height of the element is less than or up to 3 meter, the height that can be plus or minus 3 mm, that can be tolerated. Now if the height of the panel is 3 meter to 6 meter, then the tolerance that is given is plus or minus 3 mm to minus 5 mm, that is considered as a tolerance. And for a panel height up to 6 meter to 12 meter, we can say we have the tolerance limit of plus or minus 1.5 mm per 3 meter of the length. Similarly, we have another tolerance as well. So you can go through the manual in which we have all the tolerance that is suggested by the uh, manual 135. Yeah, so thank you. So this was all about the precast panel. So we have already uploaded the video on hollow core slab on this series, so you can must watch. And if you liked this video, just comment and share with others. Thank you.